All right, in the last lesson we talked about congruent figures and specifically congruent triangles, and we talked about how congruent triangles need to have 3 congruent sides and 3 congruent angles in both triangles that we're comparing. But what if we don't have all 3 sides or all 3 angles? Can we use something else? Are there shortcuts? And there are, and we're going to talk about 5 shortcuts that can prove triangles are congruent without proving all 6 of those values that we talked about yesterday. The first is called side, side, side. And what this says is if 3 sides of one triangle are congruent to 3 sides of another, then the 2 triangles are congruent. So if you look at both pictures, you see the top triangle ABC has 1 congruent mark between A and B, 2 congruent marks between B and C, and 3 between A and C. If you look at the bottom triangle, you see that side DE has 1 congruent mark. So DE is going to be congruent to side AB. If we look at side BC, that has 2, and if we look at the bottom, EF has 2. And if we look at side AC, that has 3, and so does side DF. So those are going to be the sides in each side of each triangle that are congruent. And because we have 3 sides that are congruent, the triangles are congruent. Now the last thing on the bottom here is the congruency statement. Now, because they don't tell you it, we have to set one up. So if we use triangle ABC, that's going to be congruent to triangle DEF. And if you look, angle A is the angle between the side with 1 congruent mark and 3 congruent marks. If we look at D, D is going to be between the side with 1 congruent mark and 3 congruent marks. So what you do is you use that pattern to match up the letters. So triangle ABC is going to be congruent to triangle DEF. The second shortcut is side, angle, side. In this case, it says if 2 sides and the included angle of one triangle. All right, so we need to talk about this word included. The word included is a different way to say in between. So if we reread the sentence, it's 2 sides and the angle in between them of one triangle, if they're congruent to 2 sides and the angle in between them of another, then the 2 triangles are congruent. So if we first look at the angle in both triangles in the image, we notice that angle Q is in between the 2 triangles, or in between the 2 sides that are congruent. And if we look at angle X, it's in between the 2 sides that are congruent. So that is the most important thing to know about this, is the angle has to be in between the 2 congruent sides. So if we look at the picture, PQ has 1 congruent mark. And if we look at the other triangle, we'll notice that WX has 1 congruent mark. Angle Q has a congruency mark, and so does angle X. So those 2 are going to go together. And then side QS has 2 congruent marks, and so does XY. So those will go together. So for our congruency statement, as long as we match up the letters of the vertices, it doesn't matter the order. So I'm going to give you the order, which is PQS. So P is going to go with W, Q goes with X, and S goes with Y. All right, so if we look at these examples, they want you to prove that triangle HAT is congruent to triangle SUN. They give us 2 choices that we can use. We're either going to prove it with side, 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 or side, angle, side. Based on what's given, they say HA and SU are congruent, so we need to mark that in our diagram. Then it says HT and SN are congruent. We need to mark that congruent in our diagram using 2 congruency marks. Then it says angle H and angle S are congruent, and we'll use that using our arc congruent mark. And if we notice, this is going to be congruent by side, angle, side, because the angle is in between the two congruent sides. In the next one, they want you to prove these two triangles are congruent. So again, we mark what's given in our diagram. So EB and CB are congruent. AE and DC are going to be congruent. Now, to prove this by side, 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 we would need to prove the other side is congruent. And based on what's given in the image, in the problem, we do not know enough to prove those sides are congruent. If we want to prove it by side angle side, we need to prove E and C are congruent. And based on what's given, we actually don't have enough information to do that. This one can be a little bit tricky for students because there's vertical angles in this problem. But if we notice, the angles do not go in between the two congruent sides. So this problem would actually be you cannot prove this using side, 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 or side angle side. All right, in this problem here, you can't prove this triangle is congruent by either SAS or SSS. But what the question is asking is what additional information do you need to prove it true? So based on the picture, we know that RS and KT are congruent. So right now we have one side that's congruent. We also know that KS is congruent to KS because of the reflexive property. So if we wanted to prove this true by side angle side, we would need the angle in the top triangle to be congruent where S is located, and the angle in the bottom triangle where K is located. So if we name that using 3 letters, the angles would be named like this. The top angle could be called angle RSK, and the bottom triangle angle would be called TKS. Again, connect the dots is the way I explain in class. Start at the first letter, go to the second, and then end at the third. And when you name angles in 3 letters, the middle letter is the actual angle we want. Now for side, 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 we would need to prove that the third side is congruent. So in this case, ST would need to be congruent to RK. Here's an example of a proof. So in this case, we want to prove triangle ABD is congruent to triangle CBD. So because they give us information, we're going to write the given information first. And the justification most times is because it's given. Okay, so we've written our statements, our justifications, and we've marked the triangle accordingly. So now we have to look and say, okay, if we prove this by side angle side, we would need to prove that A is congruent to C. And based on what we have so far in the picture, we don't have enough information. So then we have to say, okay, the other way we know how to prove triangles are congruent is through side, side, side. And is there a way to prove that side BD is congruent to BD? And there is, and that's using the reflexive property. So now we have 3 sides that are congruent, and so the last thing we write is the congruency statement and the justification why. And in this case, we prove the 2 triangles are congruent by side, side, side. All right, in example 5, again, we want to prove these are congruent, and they give you 2 bits of information that are given. So write the given statements, and the justifications for those 2 statements will be that they are given. All right, also mark the triangle. So now that we have an angle and a side, we can't prove this using side, 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 but can we prove it using side angle side? So if this were true, we would need the side RS congruent to side RS. And we do know that that is congruent because of the reflexive property. And so the congruency statement up top, we want to rewrite for the statement, and the reason is side angle side. In this last example, they tell you that C is the midpoint of the two different segments. So in this case, you could write that down for your statement justification, but what ends up happening, because C is the midpoint of NB, that means NC and BC are going to be congruent, because that's the definition of a midpoint, which states a midpoint splits a segment into two congruent parts. And then we can write a very similar statement and justification for the second part, where MC and AC are going to be congruent by definition of midpoint. If we were going to prove this by side, 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 we would need to prove that NM and AB are congruent, and we don't have any information in the problem to tell us that would occur. So then if we were to prove this by side angle side, we would need to look at angle NCM and angle BCA, and they are congruent because they're vertical angles. And in this case, the angles occur between the two congruent sides. So this would be proven congruent by side angle side.